Okay, this slide is not in your notes for section 9.1. You don't really need to write any of this down. This is just kind of a reminder. If we have the square root of 25, the square root of 25 is 5 because 5 squared is 25. Basically, you could rewrite this as the square root of 5 squared. The square root and the square cancel each other out. The cube root of 64 is 4 because 4 to the third is 64. Square roots undo squares, cube roots undo cubes, fourth roots undo exponents of 4, and so on and so on. So here's some properties for us to look at. If the, and we need to remember what these things are called, the little number in the check marky part of the radical is called the index. And this number is called the exponent. If the index and the exponent are the same, they cancel each other out. So the fifth root of 7 raised to the fifth is simply 7. Now, when we have odd or even indices, it does change things a little bit because we can do the cube root of negative numbers. And if you take a negative number and raise it to an odd exponent, it is still going to be negative. So negative 5 to the third is negative 125, and the cube root of negative 125 is negative 5. So if that index is odd, they are going to cancel each other out, and you will have whatever number it is under there, whether it be positive or negative. If the index is even, it's a little bit different. The square root of negative 5 squared is positive 25. What's the square root of positive 25? 5. So in this case, it's going to be the absolute value of negative 5, which is positive 5. So I'm going to add a couple down here just to make sure you understand this. If we have the third root of 5 to the third, it's going to be 5. If we have the fifth root of negative 10 to the fifth, it's going to be negative 10. If it's an odd index, if your original number is positive, your answer will be positive. If your original number is negative, your answer is going to be negative. So odd index, the number matches positive or negative. Now if it's an even index, like if it's the fourth root of 5 to the fourth, it's going to be 5. If it's the fourth root of negative 10 to the fourth, it's going to be positive 10. If it's an even index and an even exponent that match, take the positive of whatever that number is. The next property we're going to talk about is rewriting radicals in rational exponent form or rewriting rational exponent form in radical form. The property is that a raised to the 1 over n is the same as the nth root of a. The bottom of that fraction exponent is the same as the index. So let's actually start, let's add one. Let's do 27 raised to the 1/3. That bottom number of the fraction is going to be the index of the radical. So it's going to be the third root of 27. Now let's look at 9 raised to the 1/2. What would 9 raised to the 1/2 be in radical form? An index of 2 with the 9. Now the question is, do we really need to write an index of 2 in that little index spot? No, I won't count it wrong if you do, but you don't need the 2 when it's square root. And when you see a radical with no index, you have to remember that that is a square root. It's a 2, not a 1. Okay. Property 2 just expands on this. The bottom number is still going to be the index. The top number becomes the exponent. And there's 2 ways to write this. You can either write it with the exponent underneath the radical, or you can write parentheses around everything and the exponent on the outside. I think it's easiest to write this format. So 8 raised to the 2/3. The bottom part is the index. So this is the cube root of 8. And that top number is going to become your exponent. So it's 8 raised to the 2nd. You could also write this as the 3rd root of 8 in parentheses raised to the 2nd. Both of those mean the same thing. Practice these skills by filling out this table. Pause the video, fill it out, then play to check yourself. This first one, remember when there's no index shown, that means it's a square root. So this is 5 to the 1/2. The next one, if the index is 2, you don't have to write the index in there. I won't count it wrong if you do, though. The square root of x to the 5th. This one would be m to the, anyone? 7/3. 4th root of 72 raised to the 3rd. And the last one, y to the 1/4. Okay. The next slide is really just a reminder of all of the exponent rules that you've learned over the years. You started learning these in Algebra 1. We went over these again in Algebra 2. I do have a little helper to help you with numbers 1 through 5. If you write the word PEMDAS with 2 letters per line, this is a visual clue to help you remember your properties of exponents. If you see parentheses, you are going to multiply your exponents. If you see multiplication, you are going to add your exponents. If you see division, you are going to subtract your exponents. So whatever operator you see, you do the thing below that with the exponents. That will help you remember basically exponents 1 through 5, or rules 1 through 5. 0 exponents, anything raised to the 0 power is always 1, and negative exponents move. So take a look at number 7. If we have something with a negative exponent, it moves to the bottom and it's 1 over whatever that thing was with a positive exponent. On the next page, the problem is we cannot combine y and the 4th root of y squared because they don't have the same type of radicals. But we can convert these into rational exponents and then use our properties of exponents. So this plain old ordinary y is a y to the 1st. The 4th root of y squared is y raised to the 2/4. When we are multiplying, what do we do with our exponents? We add them. So we need to do 1 plus 2/4. If you have a calculator, like you could add these like on paper, get common denominators, do all that business, or you can grab your calculator. If you have a graphing calculator, you type in 1 plus. To do the fraction 2/4, just use parentheses and the division key. So parentheses 2 divided by 4, close your parentheses, that's the fraction 2/4. When you hit enter, you get a decimal. You need to memorize, if you're using the graphing calculator, the keystroke math, enter, enter. When you go into the math button, the very first option is change to fraction. So you hit enter and then enter again. Math button, enter, enter, and it changes your answer into the fraction 3/2. If you are using the trusty scientific calculator from the days of middle school, you would do 1 plus 2, your ABC button, 4, and then hit enter. I forget what that ABC button looks like, but it's the A, B over C thing. It's going to give you the answer 1 and 1/2. We don't want mixed numbers. Your scientific calculators are stuck in middle school and they still think that mixed numbers are better. If you push the second key and then your ABC button again, it will change it into a mixed number or an improper fraction 3/2. If you need help figuring out how to do fractions on your calculator, please come talk to me. I will help you get it figured out. So if our new exponent is 3/2, that means our answer is y raised to the 3/2. I was always taught if it starts as a radical, it needs to end as a radical, but basically according to your book, they just want you to get it to that simplified form and then be done with it. So y to the 3/2 is our answer. Okay, example B. The top says the 4th root of t. How does that look as rational exponents? T to the 1/4. And on the bottom, we have the square root of t to the 5th. That is t to the 5/2. When we're dividing, what do we do with our exponents? Subtract. So 1/4 minus 5/2. Try that on your calculator. 1/4 minus 5/2. Get it changed into an improper fraction. This means we have t raised to the -9/4. We cannot have negative exponents. So t to the 9/4 needs to go to the bottom. Can't have a naked numerator. What number is in the numerator? 1. And that would be our final answer. I would like you to try C on your own. Pause the video, try C on your own. No, that fraction is not wrong. It is 19/15, so y to the 19/15. Okay, last thing today is domain. This is mostly easy. If your index is odd, your domain is always going to be all real numbers. So if I say that we have a function that is the cube root of x plus 10, the domain is going to be all real numbers because it is an odd index. If the index is even, we have to make sure that the stuff under the radical is greater than or equal to 0. So let's try this because it's easier just to see it in action. In example 3a, is this an even or an odd index? Even because it's square root. So this is an even index. When your index is even, the stuff under the radical has to be positive. So put the stuff under the radical greater than or equal to 0 and solve that inequality. How do you solve that? How do you get x by itself? -7. So x is greater than or equal to -7. Your domain is x is greater than or equal to -7. This means if you choose an x value bigger than -7, this function works. If I were to choose -10, -10 plus 7 is -3. We can't do the square root of -3. You can't do the square root of negative numbers. You can't do the 4th root of negative numbers. You can't do the 6th root of negative numbers. So B, this is a 6th root. That's an even index. So you put the stuff greater than or equal to 0 and then get x by itself. It already is. So your domain is x is greater than or equal to 0. In C, do we have an odd or an even index? What is the domain for odd index radicals? All real numbers. Don't have to do any work, you just write all real numbers.